All right, here we go with number 2. A management firm has determined that 60 apartments in a complex can be rented if the monthly rent is $900, and that for each $50 increase in the rent, 3 tenants will be lost with little chance of being replaced. Okay, we'll read the rest of it later. But whenever we do revenue questions, we always have to identify that each or every change that's happening. So the change that they're looking to put in place here is an increase of $50. And they might do that once, or they might do it twice and increase it by 100, or they might increase it by 53 times, and that's increasing to 150 and so on. So the first thing we need to do is write a let statement. Let N represent the number of $50 increases. So start with that. Find your each or every, and then write your let statement based on that. All right, now we write our revenue statement. So revenue, let's call it R at N. Let's use function notation this time. Revenue based on the N value in our let statement is still price times number sold. So let's start with price. Price times number sold. What's the price right now? The price right now is $900. And we're looking to increase it. Increase means plus. Increase it by $50, but not necessarily just once. Maybe increase it by $50 twice, or 3 times, or 4 times. So we need to multiply 50 times 1 or 2 or 3 or whatever. All right, similarly, right now, the number sold or rented out is 60 apartments, but we're going to lose tenants. It says 3 tenants are lost. Now we're going to lose tenants as we increase the price, and we're going to lose 3 every time we increase it by $50. So 3 times N. So there's our statement. Now, let's read the rest of the question. What rent should be charged to maximize revenue? Well, here we have an expression that is not in vertex form. In fact, it's not even in standard form at the moment. So we should switch it to one or the other. Let's just expand it. 900 times 60 is 54,000. Then the outside, I'm doing FOIL. First times first, 54,000. First times last, negative 2,700 N. The insides, 50 times 60, 3,000 N. And then the last one in each bracket, positive times negative is negative. 50 times 3 is 150. And N times N is N squared. All right, that's starting to look a little bit like standard form. All I have to do to make it really look like standard form is put the squared term first. Just recognize, though, that this negative belongs to this term. So if I'm going to move this term to the front, I bring the negative with it. Negative 150 N squared. These two will be my next term, but they're like terms, so I can combine them. Negative 2,700 plus 3,000 is positive 300 N. And then 54,000 is my last term. Notice it's positive, so I bring the positive here. Okay. Now, if we want to find what rent should be charged to maximize the revenue, then we would need to find the vertex of this parabola, because that's where you find a maximum, so long as it opens down. Does this one open down? Yes. So that means a parabola that opens down is going to have a highest point, which is a maximum. So we need to find that highest point. Well, that highest point is the vertex. Now we have some choices. How would you like to get the vertex? Would you like to complete the square, or would you like to use what we used in number 1? Okay, you want to use the shortcut. I don't blame you. H equals negative b over 2a. What is the b value? Well, it seems quite clearly to be 300. This is a, like the x squared, plus bx plus c. So this is the b over 2a. The a value is obviously negative 150. So that simplifies to negative 300 over, what's 2 times negative 150? Also negative 300. Negative 300 divided by negative 300 is 1. Okay, so what does that mean? We have found the first coordinate of the vertex, and it's 1. How do we find the second coordinate of the vertex? This is true all the time. The minute you have one of the coordinates of a point on any curve, parabola, straight line, anything, if you have one, you can always plug it back into your equation to find the other. Now, last time we plugged it in, once we got our 2.5, we plugged it into our revenue function that we made in standard form. But we could have just as easily have plugged it in from the beginning. So this time I could plug it in here, but just to show you that they both work, I'm going to plug it into here. So revenue when n is 1 is 900 plus 50 times 1, 60 minus 3 times 1. 50 times 1 is just 50, and 3 times 1 is just 3. So we get $950, 57 tenants. And when you multiply those together, you'll get 54,150. Okay, I'll write it here in my ordered pair, 54,150. All right, so now we can write our final statement. What rent should be charged to maximize the revenue? Be careful here. The answer is not $1. The answer is the price or the rent that you get when you increase the current rent by one set of $50. And that's represented right here. A $900 increased by one set of $50. That's $950. So rent must be $950 to produce. I'm going to do my let statement for both of these questions in one. Rent must be $950 to produce maximum revenue of, and that's where you need your Y value, or K, which is 54,150. Done.